In this lesson, we are going to create a 3D text that you can see on my screen right now, but with React 3 Fiber. And you might think that, yes, we already did that lesson, but that's a perfect opportunity to do it in React 3 Fiber because we already know how to create those things in native, and we're going to do it in React 3 Fiber so that we can compare. We understand what's the difference when doing it in native and in React 3 Fiber. So hey, we have enough knowledge to start building our own experience, and we are going to do one or two lessons like this by just recreating old lesson, and then later, don't worry, we're going to create a new projects using React 3 Fiber. You're going to see it's going to go quite fast because well, with React 3 Fiber it's super fast, and we already know the basics like the torus geometry, the text geometry, the various parameters, etc. Okay, about the setup. So this is the final result. I'm going to get back to the setup that you can start with the classic npm install, npm run dev. And we have only one cube like this with the mesh normal material. We don't really care about the mesh normal material. It's just like orientation of the face relative to the camera. It's to have something on screen. We have perf right here so that we can keep an eye on performances. And this is actually important because we're going to do some tweaks according to performances. We already have Dre in the project, and we are using only orbit controls from Dre to be able to rotate around. Nice. Okay, let's start with, well, the actual main component of this experience, which is the text. And we're going to use the text 3D helper. We are not going to use the text helper. If you remember from previous lessons, you know, with I think it's when we tried Dre helpers, we discovered that there is a way to create text using SDF fonts, and by using the text helper from Dre, we are not going to use this one because we need 3D. We need to add depth to it, so we need a whole geometry, a 3D geometry, which is why we are not going to use this one and use the classic text 3D helper. So let's go. We need to use the text geometry, and Dre provides a helper named text 3D that implements it. So in experience.js, I think we are going to put the whole code inside the experience.js, but as always, it's better to separate things into components. But you will see that the code is going to be quite simple at the end, not too big, so we can put everything in the experience.js. We're going to import that helper I've been talking about for a few minutes already, which is text 3D. Be careful, the D is uppercase. We saved. Okay, cool. We can continue. To use the text 3D, and maybe you remember from the previous lessons, we need to provide a typeface font. All right, it's a very specific format of font, and we need to provide this one. There is already one provided with the lesson. Let me show you. It's in the public folder, in the fonts folder, and it's Helvetica regular. All right, I think it's kind of the free, the public version of Helvetica, and we can use this one. Great. You can create your own typeface. I'm not going to spend too much time on this part because this is what we already explained in the text 3D lesson with native 3GS. So I'm not going to spend too much time on it. Still, quick reminder, if you have a specific font, like I don't know, you have the font in your computer and you want to create a typeface version, you can use that website right here. As always, check the links in the tab, links right below. And this will try to convert it to typeface fonts that you will be able to use. You put it inside the public folder and you can try to use it. If you tend to use a font, especially online, not just online, but especially online, you must have the rights, all right? Check the license, make sure that you are allowed to use the font. It's not because you can download the font somewhere that you can use it on whatever project. For personal usage, only on your computer and you won't show your project to anyone, it's fine. But if you put it online or it's for printing or whatever, make sure you have the right to use the font. So let's go. We have the helper right here, and we're going to add it to the scene. I'm going to add it at the end of the GSX. So it's going to look something like that. So text 3D. I open and close it separately because I'm going to put a text inside of that, and I'm going to write hello React 3 Fiber in uppercase. You can write whatever you want in there. And for the font, because yes, we need to provide that typeface font I was talking about, you add a font attribute like this and you provide the path to that font. And I'm going to provide the ./font because I remind you that it's in the fonts folder, and then the whole name, which is Helvetica _ regular typeface.json. So it's a bit long. And here you go, you have the text. That was so fast, and we are done. I see you in the next lesson. Just kidding. Obviously, we have some work to do, and we are missing the donuts. But see how fast it was? And it's working. Nice. A mesh basic material is applied, but we can change it by providing another material. And it works like we used to do for meshes by adding something inside of this one. Actually, we can be lazy and just take this one here and put it there, and it's working. Nice. Actually, that's the one we were supposed to use. That's perfect. And we can move forward. We can remove the cube. All right, the cube was just there so that we can see something in the scene and make sure that the starter is working for everyone. We don't need that cube in the final project, and we get this. So we have some work to do about the parameters, about centering the text, and we need to add the donuts, and we are actually going to go a bit further than the initial lesson. Let's talk about centering. Do you remember how we did it in the previous lessons? We offsetted the geometry itself by using the bounds. You know, we calculated the almost automatically calculated bounds of the text, and using that those values, those coordinates, we moved it half back on all three axes so that the text is centered. It's a viable solution, but we are here to discover some reactive fiber. We are going to use the center helper that you can find on Dray. So first we're going to import center, like that. And then we are going to wrap the text 3D into center, like this. Okay, make sure you have the right indentation, as always, very important. Although it won't break your code to write it like that, please have a good indentation. Next, so as you can see, it's working. The center will calculate the bounds automatically of what's inside and move it so that it's centered on its center, so the center of the scene, because that's all we have in the scene, and it's working. So cool. It's actually not moving the geometry. All right, it's moving stuff. I think there is a group, and then it's calculating what's inside, the bounds of everything that is inside. You can have multiple objects inside, and then it's moving everything at once inside the group. Anyway, we don't really care. It's centered. That's so cool. About the parameters, as you can see, we have the right font, okay, but it's a bit thin. There is no like round corners that we have in the initial lesson. So we're going to provide a bunch of attributes, and those attributes comes from the text geometry. You can find them on the text geometry documentation. You have the size, the height, the curve segments, the bevel enabled, the bevel thickness, etc. We are not going to cover those parameters because we already did that in the initial lesson. I'm just going to provide you my settings. You do whatever you want. If you want to start by putting the same settings as me and then tweak them, be my guest. So size, I will do them with you anyway, so that you can just follow. Size is going to be 0.75. Height is going to be 0.2. Curve segments is going to be, I think those are almost the same as the initial lesson. Curve segments is going to be 12. Bevel enabled is going to be true, and we can just provide bevel enable, just providing the attribute makes it true. Bevel thickness is going to be 0.02, like this. Bevel size is going to be 0.02 again. Bevel offset is going to be, I actually don't even remember what are those. I just tweaked them until I was happy. And bevel segments is going to be 5. And we get something like that. All right, it's a bit more round. Let me check that I have the right values. Yep. Yeah, it's working. Nice. By the way, what about using Leva, so debug UI, for those parameters? Is it good? Is it okay? Can we do that? Well, yes, we can. We're not going to do it. We can, but be careful. When you change those attributes, the geometry will be disposed and recreated. So you be careful with that. I mean, it's fine if you want to just use Leva to find the perfect values. That's okay. We don't care that it takes, I don't know, like a tenth of a second to recreate the geometry. It's fine, but maybe don't animate those values like in in a loop or something like that on each frame, don't animate those values. It will be too much, especially if you have a lot of vertices. Anyway, let's move forward. That was not the topic. And we're going to change our mesh normal material because we need something a bit cooler than that. And we're going to use the classic madcap material technique that we use in the initial lesson. So first we need to load the madcap texture, and we haven't covered that. I know we are maybe at the seventh lesson of this whole new chapter, and we still haven't loaded a texture. Actually, we are not going to just load a texture. We're going to use a specific helper to load madcap texture. But don't worry, in one of the next lesson, maybe just the next lesson, you will learn how to just load a texture, which is super simple. Don't worry, it's really easy. And for now, we are going to load madcaps and specific madcaps. All right, so let's discover that. We're going to use a Dre helper named use madcap texture. So use, as always, it's a hook, and it will load madcap textures. That's just too cool to be true. It will actually load them from this repository that maybe you have already seen. Check that. We have a bunch of madcaps available right here. So many madcaps, so cool, and we can just use them. So that's super cool, and they're going to be loaded automatically by using that helper. By the way, since they are being loaded from that repository, be careful. It's maybe not a good idea to use them for, I don't know, like clients projects, because you rely on that repository. Maybe there is a CDN somewhere where you have those images. Maybe it's straight from the repository. I'm not sure, but anyway, be careful. If someone decides, the owner of the CDN or the GitHub repository decides to remove them, well, you're going to your project won't work anymore. You won't be able to see the madcaps. I think the project will keep working, but it will be a default material or something like that. So be careful with that. I'm just warning you. Anyway, we're going to use it because we are here to just discover stuff and use it. So let's go. We're going to import that hook. So it's going to be use madcap texture like that. So singular. And then right here, we're going to load. So inside the expanse, we're going to load that texture. So we're going to do const madcap texture because we get the texture. Use madcap texture. And in there, we're going to provide the ID, kind of the ID of the madcap. So I have a very specific one here, but if you want to find a madcap, let me see, we can do maybe that. Yeah, see that? See how it works? You can click on whatever madcaps you want, and let me check. Yeah, I don't know where is this one exactly. I think it's on the page. Yeah, maybe it's this one. Let me check. I think we're going to use this one. Yeah, see? So you have the link, by the way, in the tab link. So if you want to use the exact same as me, use that one here. So from the link, check the link, find the madcap, and see that number on top of this madcap. So this is the madcap, this is the result. That's the number, that's the ID of the madcap. So that's the one you need to use there, okay? And if you want to find another one, you have the link to the whole repository. And I don't know if I want, well, that's the one I think I was using. If I want to use, I don't know, this one that looks super cool, I just click on that one. It's the page 15, which is already on right here. So this is just like the pagination of all pages. We are already on the page 15, and it was over there. So you can use this one. All right, so don't spend too much time choosing the one you want. I know you can get lost for, I don't know, like half an hour just trying to find the perfect madcaps. Just choose one randomly for now, and once you have something on screen, you'll be able to really see the result and maybe find a better madcap. All right, so back to that. You chose one, maybe you chose the same as me, and here we need to provide a number, and I'm going to provide 256. If you reload the page, we see that you get 2 console right here. You didn't do a mistake like, I don't know, putting 2 console log and forgetting 1. Actually, we get 4 now, so it's even worse. No, it's because our component is being re-rendered. And it's being re-rendered because of that helper right here, the text 3D. I'm guessing that when the font is being loaded, well, something is different and the geometry generates itself, so it's triggering re-render, which makes sense. It's totally normal. You can just, it's no big deal. You can just continue. It's normal. The component is being re-rendered. So just keep in mind that you might see double consoles right here. It's just fine. It's okay. It's a normal behavior. So about the parameters, I already told you that the first parameter is the name of the matcap, kind of the ID that you can find on the repository. You can spend some time finding the perfect matcap if you want. And the second parameter is the desired width, and we can choose between 64, 128, etc., etc., etc. I don't think they are all available for all matcaps, but don't worry, I think there is an automatic fallback. Like if you try to get this one, but only this one is available, it will load this one. Anyway, the rule is always the same. Try to use the smallest possible so that, well, it's better for performances. It's not much. It's just a matcap. But if you send too much textures to your GPU, the performances will start to get worse and the frame rate might go down at some point. Okay, use matcap texture. As you can see, it's not returning just a texture. It's returning an array. And that array contains that texture, and it's a Three.js native texture. And you also get the link of the matcap and some number, and I think that's the actual size of it, because maybe the one we ask, this one is not available at that size, so you get something else. So it's kind of a bit random. If you test other matcaps, you will see that you might get other sizes. So put a small number and check what you get here if you're curious. Anyway, it's going to work, and we can continue. So in our case, we just want the texture. Okay, so we are going to destructure it, and since it's an array, we can destructure it by using brackets like this, and we only want the first value, and that's the actual texture, and we can keep naming it matcap texture. So you save, you give it a reload, so we get twice because there is a re-render. We don't care about that, and we get the texture, and we can use that texture. Next, inside the material we have here, we are going to replace this one by a mesh matcap material. So let's go matcap material, and to provide the matcap, we can just put matcap, inject something, and put matcap texture. So our texture like this, and check that out. It's working. You might have seen, I did it a bit too quickly, but you might have seen a version that is not, it's a bit brighter. We're going to talk about that later. It's about the encoding. Anyway, just give it a reload if it looks too bright, and it should be fine. In this example, we're going to stick with bright colors to change from the original 3D text a bit. Yeah, by the way, I forgot to tell you that, but we are not going to use the kind of the dark textures that were looking really good, but a bit too dark. To differentiate a little, we're going to make it a bit brighter, but have fun. If you want to play to use a different matcap, you can also change the background. You already know how to do that. There are multiple solutions to change the background. Have fun, create the style, use the style that you prefer. Okay, we have the text. As you can see, it was quite fast. We just put a bunch of parameters here and had a bunch of tags, sorry, and had to provide the font and the texture that we got from the matcap repository. We can remove the console log, by the way. Let's take care of the donuts. And as Homer Simpson said, donuts, is there anything they can't do, right? So we need a bunch of donuts. We're going to create a first donut, just to make sure that we can get that donut, and then we're going to add more donuts and discover some features along the way. Let's go. First, we're going to create a mesh. You can put it wherever you want. I'm going to add it at the end of the GSX like this. I need a donut, so it's going to be a torus geometry. So let's go, torus geometry like that. And then we can just save this and we get kind of a torus, although it's a bit weird. But let's continue. I'm going to keep the default parameters and add one more tag in it, which is a mesh matcap material. And let's be lazy and use that mesh matcap material here, because it's the same matcap. You can use different matcaps if you want, but it's working nice. Unfortunately, it looks a bit too PlayStation 1 graphics, so we need to improve that a little. And if you remember what we say in previous lessons, when you create, I don't know, like a torus geometry, you can use the parameters that you find in the Three.js documentation. Those are the same parameters in the same order. So radius, tube, radial segments, tubular segments, arc, etc., etc. And you provide them in the args, like this, args attribute. and we send an array. Okay, don't make sure to send an array. I always forget about this one, but yeah, send an array and put the parameters in it. So it's going to be 1, 0.6, 16, 32. Don't put too much vertices right here. This is more than enough. Save, and we get a chunky donut, just like we like them. All right, so we have one donut that was super easy. Maybe you got it working on your own. Congratulations. But now we want multiple donuts, and that's very interesting. We could just duplicate it. Don't do it, but I can show you. Like I duplicate it, and then I change the position, the rotation, etc. But it's not going to look good. It's not going to look random. It's going to be a pain in the ass to update. So we need to find some better ways. We're going to use the map. Do you remember from the previous lessons how to use the map to create a loop? Because remember, we can't do a for loop in JSX. Right here, we can't do a for loop just like that. So we are going to use the classic map method. There are other methods, okay? If you're a React user, you're probably thinking maybe we could use the array and provide the length, etc. We can, and there are other techniques, even more techniques, but let's stick to the one we already used. I'm going to do it before the return just for a quick reminder, but when you create, let's say, a temp array, so const temp array, I'm going to go quite fast on it because we already did that. You console log that array, so console.log temp array. What do we get? We get an empty array. All right, no trick here. If we provide, instead of that array with brackets, we provide array with uppercase A, so it's in Pascal case, and then 100, what do we get? Well, we get an array filled with 100 empty. That's a bit weird, but its length is 100, but the array is still empty, okay? Yeah, by the way, the array is being logged twice because of text3d. I already told you about that. All right, so can we map on this one? You remember? Unfortunately, no. If we try to map on this one, let's say console log value, any value, we don't really care. I get nothing. All right, I saved the file and it's not working. I get nothing because the array, yes, it's 100 long, but it's still empty and we can't loop on it. So we're going to convert that array. So we keep that, but check that trick. We're going to put it inside another array. Okay, I just added brackets around it and put the spread operator. It's a bit weird, but now it's working. Okay, if you give it a reload, you get 200. Remember, it's because it's been logged twice. If you had a console log before, like log like this, and just something to separate, as you can see, it's getting log once. We get 100 in it, so it's working. And then the component is being re-rendered, which is why we get 100 again. So I'm going to remove this one. So what we get here is an array, which is filled with, now it's not just an empty array, it's going to be filled with undefined. Check that. A huge array filled with undefined. And that's just like a JavaScript trick to create an array filled with nothing that we can use it, that we can then use to map on it. Okay, I'm not spending too much time on this one. Let's use it now in the JSX. So I'm going to comment this one so that I have it somewhere to make sure that I can reproduce it in the JSX. We're going to inject something. So it's going to be the array in which we spread the array we created as 100. 100 donuts is just fine. You can add more if you want. And that's the way of creating an array on which we can map. And then we map on it. So it's going to look like that. And in there, I'm going to provide a function. All right. This function will be applied on every element in that array. And it will return something. We don't care about the element in that array. All we care about is returning something 100 times. And in there, we can return the mesh. So instead of doing that, I'm going to remove the curly brackets. So the opening curly bracket and the closing curly bracket. So you get this. And now I'm going to send the mesh in there. So I'm going to cut it and send it there. And I'm going to save. And it's working. I know there is an error, but don't worry, it's working. It's about the key thing, maybe you remember. We can do some quick refactoring. I'm going to put the mesh below, indent once, and put the parentheses, this one, right here. I think it makes a bit more sense. You can change it the way you want, the way you call the map, the indentation, the line breaks, etc. You do whatever you want, but I like this way of coding. So it's a map returning a mesh on each element of the array, but we don't actually care about the element of the array because they are all undefined. We are just returning 100 meshes. And in here, you have 100 meshes, and you can actually see it because check that. We have 101 geometries because there is also the text, which is actually a problem, and we're going to fix that because we can use only one geometry. But anyway, we have 100 donuts, so it's working. We're going to add some randomness to those meshes, and we can do it right here. So we are going to start with the position. We provide a position attribute. We inject an array, so x, y, z. And on the x, I'm going to send the math random minus 0.5. All right, so that this right here, what I selected right here, is going to go from minus 0.5 to positive 0.5, so that it's as negative as positive. And then we're going to multiply it by 10 so that it goes from minus 5 to positive 5. And then we're going to add a comma and duplicate this line so that we can do it on the y and on the z. And I'm going to save and check that. We get a bunch of donuts, so it's working nice. We need to work on the scale and the rotation, but we get some random position. And if you give it a reload, you get a different set of positions. Next, we can do it on the scale. So scale equal, we inject something. And remember, we don't have to provide an array because we want the donut to not get flat or weird or whatever. We just want the same scale on the X, Y, and Z. And in React 3 Fiber, on the meshes, you can just provide one value. I don't know if I provide 0.2, there will all be 0.2 on the X, Y, and Z. Obviously, we need some randomness, so I'm going to do 0.2 plus, so that they are not too small. Math random multiply by 0.2 again. So it's going to be between 0.2 and 0.4. Let's go. We get something like that, and it's almost done. All we need to do is play with the rotation. So let's go. Rotation equal, and this time we're going to provide all three values. Sorry. So all three values, and it's going to be, oh, never mind, just on the X and the Y, because if you rotate something like 260 degrees randomly and on another axis randomly, you get a full random. It doesn't really matter to do it on the third axis. So math random multiply by math pi, and I just do half because the donut is symmetrical, so we don't need to do a 360. 180 degrees is enough to make it look random. And on the X and the Y and on the Z, we can just put 0 and it will look random like that. And it's working. And we are done with the lesson, at least the native version, because we are going to go a little further now. Also, we did some mistakes. First of all, if you check the console, this silly error that has been around for a moment, it's not you that did a mistake. I mean, the experience is working, but it's about the key. You know, when you loop, when you provide React is using the list term. So you are doing a list of meshes. You need to provide a key when you do that, right? It's the rule. React will use that to optimize your application, especially when things are moving, changing, because it's some users and the user disconnects. So we need to remove that user, and some user are connecting, and then it's ordered by the score in the game, and then the order is going to change. And React needs to identify those items in the list in a very specific way. So this one, his ID is that. This one, his ID is that, its ID is that. So React is going to use the key attribute. If possible, you need to provide an ID, a unique ID, but we can't right now. We are just doing a list in order to have a bunch of donuts. They don't have an ID, so we're going to use the index of the map, because you can get the index in the map right here. So you can get the value. We don't care about this one, it's undefined, but we have to put it so that we can get access to the index. Like this, like we did in the React lesson. And we can use that index right here. All right, it's just to get rid of that error. Give it a reload so that we get it from the beginning. It's just to get rid from the React error, okay? If possible, use an ID, especially if you get something from, let's say, an API. Usually API provides you an ID. So we did other mistakes. First, let's talk about optimization. We made performance mistakes, and the first one is about the geometry. Check that. We have 70 geometries. That's weird. Shouldn't we have 101? Well, it's because some donuts are outside of the camera view. They are outside of the frustum culling. So, I mean, it's the frustum culling. They are outside of the view. If you zoomed out, see, we get all of them because some of them just entered in the view, and the WebGL rendered them. So it had to save the geometries on the GPU, etc. So give it a zoom out if you want to see how many geometries you have. We have 101 geometries. That's a huge mistake because can you count how many geometries we can have? We can have 2 geometries, one for the donut and one for the text, and then reuse those geometries like we did in the initial lesson. So we need to do that. It's not because we are using React 3 Fiber that we should not optimize those things. To fix that, we are going to do a silly trick first, okay? And later we're going to do another way of fixing that issue, which is a bit different and a bit less silly. You will see. It's up to you to decide which one you prefer. I'm going to show you both solutions. We're going to create the torus geometry because the issue is with the donuts and the torus geometry. We're going to create that one outside, okay? Outside of the mesh, which will break our mesh by default. Then we are going to store this torus geometry by using a use state, and then we're going to put it back on the mesh by setting the geometry attribute. It's a bit silly because we have some ping pong stuff happening between the attributes and the elements, and it's going to work. It's really a bit weird, like to really understand what's happening. Like this thing is going there and then there and then there, and we reuse it and really it's working. Okay, why not? And at the end we get only one geometry, so it's going to work. After that, I will show you a better solution. Yeah, so let's go. I told you that we are going to put it outside and then save it by using a use state, which is a bit weird, but that's what we are going to do. So first, we are going to import use state from React. So import use state from React, like that. We can get rid of that temporary array that we had. You probably removed it already. And in there, we're going to, I can do it like at the top, like this. Const, we're going to have a torus geometry state and a set torus geometry, so the setter. It's a classic use state, all right? Then we call use state like that. No error. Yeah, okay, it's fine. Next, check the torus. So my torus is right here. We're going to move it outside. I'm going to add it at the very beginning of the JSX. You will see why a bit later, so that we have everything gathered together. So take the torus geometry, this one, and move it at the very beginning, or actually maybe just after the orbit control. It just needs to be before the center. Okay, if you save now, it's broken. We lost the donuts because there is no geometry in there. React 3 Fiber doesn't provide a default geometry. The React 3 Fiber doesn't know what you want as the geometry. For the material, it's okay. Let's put a mesh basic material, white mesh basic material, or gray, or whatever. But for the geometry, it could have been a box or whatever. Anyway, we now want to save the geometry inside that state. How can we do that? It's really silly. That's not the initial purpose of state and things like that, but you will see that it will work. We're going to do it like if it was a reference. It's not a reference. We haven't imported use ref. We have imported use state, but you will see that it will work by doing that. Just ref attribute on the geometry that you put outside of the mesh. And in here, we're going to provide the set torus geometry, the setter of the torus geometry. And by doing that, just doing that, it will save the torus geometry inside the torus geometry state, this one here. I know it's a bit weird, but when you send a function like this, it's like if it was doing, don't write it, I'm just doing it for the example. It's like if you were doing this, check that. A bit like that, so I'm going to remove that. It's like doing this set torus geometry, and you provide the torus geometry. This is not going to work okay? But that's the idea. We provided the setter to the ref, the function will be called, and the actual element will be sent as the parameter, so it's going to set it inside the torus geometry. A bit weird, but you will see that it's going to work. And next, so we have the geometry saved in there. We can use it back on the mesh right here. And instead of adding it, well, inside and it will be assigned automatically, we are going to provide the geometry attribute like that. And we put the, sorry, it's just torus geometry like that. And the geometries are back. Give it a reload and check that we have only 2 geometries. And even if I zoomed out, we still have 2 geometries. So it's working. Next, let's do the same for the material. In the shaders of the performances monitoring, so this part here, as you can see, there is only one shader because Three.js automatically reuses shaders when possible. And right now, well, we create one mesh matcap material, but in Three.js, in the WebGL, it's just one shader, right? And then some different parameters, uniforms, etc. Internally, we don't have to do it, but internally, some different parameters, uniforms, attributes, etc. will be sent to that shader. But anyway, we could just keep it like that. In terms of performances, it's fine. But we're going to optimize it anyway, at least so that we have only one position, one way to offsetting those materials, because right now we have it there and we have it there, and we could have more objects in the scene. So we are going to do the same as we did for the torus geometry by putting them outside so that we can control the whole scene with just the torus geometry, the material, etc. If you want to change the matcap and change the material to something else, you can just do it from here. So let's go. First, we're going to move it outside. So again, you take it right here and you put it right there after the geometry. Why not? It has to be before the text 3D and the center. And in there, by the way, since there is nothing inside the mesh, check that part here. There is nothing inside the mesh. You can keep it like that, or you can auto-close it. And I prefer to auto-close it. If there is nothing inside, I auto-close it. All right, so if I save now, what changed is that the donuts are using the default material. We are not handling this one yet. Don't worry, we are going to change it right after anyway. Let's focus on the donuts for now. Back to the use state thing, we're going to duplicate that line because we are super lazy and create a material, just material, because it's not the donuts material or torus material, it's going to be used on the text too. And for the setter, we call it set material. That's the only material in the whole experience, so we can name it like that. Then in there, we're going to provide the ref attributes. We are doing exactly the same that we did for the geometry, and it's going to work. And we provide the setter, okay, the set material like this. By doing that, we are saving this mesh matcap material in this material state. Nice. Finally, in there, so for the mesh right here, we're going to provide the material, and it's just going to be the material state, this one here, and it's working. And then for the text 3D, we're going to remove that one, okay, back to the text 3D. We have the mesh matcap material here. I'm going to remove this one, and I'm going to provide the material like this. Material equal material, just like that. And we have now only one material here to control the material of the text and the donuts and whatever object you add in there. Nice. This is working, but I'm not a big fan because it's over complicated. There is this ping pong thing happening where you create a state, you set it there, so this one gets updated, and then you set it there. It's a bit weird. I think it makes the application a bit more complex. Sometimes you have no choice, but sometimes you have choices. And we are going to do a different solution, which is a bit silly too, a bit out of the box, and you will see how. Yeah, actually, let's do it now. We're going to create the geometry and the material before the experience. All right, we are going to create them right here and use them right here. So we can't use the use states and the various hooks and the phases of React or whatever. We're going to use native Three.js to create them outside. So first, let's do some cleanup. I'm just going to comment them. You can remove them. We are not going to reuse them. So I comment the use state. Let me check what we need to comment. Yeah, we can comment those in here in the GSX. And I think we also need to remove them. Yeah, those for now, you can keep them. Don't save because you're going to get an error. I mean, you can save, but you will get an error because the material doesn't exist and the torus geometry doesn't exist yet. Now, since we are doing some native 3GS, we can command the useState too. We're not going to use it. Since we are doing some native JavaScript and native 3GS, we need to import 3GS. So import all as 3 from 3, like that. And in there, right after, we're going to create those two variables, and we're going to use the same name so that we don't have to change them right here. So we're going to do const torus geometry. It's not going to work right away, you will see why. New 3 torus geometry, and this is native 3GS, and we can do that. And we provide the same parameters, so it's going to be 1, 0.6, 16, and 32. Next, we need to provide a material, and there is an issue right here. New 3.mesh matcap, so matcap material. See the issue? We can't provide the matcap texture because the matcap texture is being handled in there. So we have an issue. To start with, we are going to provide a default matcap material so that at least we have something working. And as you can see, there is a default matcap material, so that's fine. At least we can see something on screen. But we are not using that texture that we loaded using the use matcap texture because we can't just do something like that. Don't do it. It's not going to work. We can't do, something like that. This variable here doesn't exist. It starts existing when the experience is being rendered. So we need to find another solution. So let me get back to the initial code. Okay, nice. Since we want to apply the texture only once, maybe when I say that, you should think, okay, I know what we are going to use. We're going to use the use effect because we are going to do it right here in the component so that we have access to the matcap texture, but we want to do it only once. We are going to update the material in there by using that matcap texture only once on after the first render, and we can use effect to do that. So let's go. We're going to import it. I'm going to import use effect. So I have the use state so that this code can work if you want to uncomment it, but the use state, you can remove this part. And in there, I'm going to call use effect, and provide a function and an array of dependency, and I'm going to keep it empty like that. Okay, so that this function will be called only on after the first render. And in there, we're going to update our material that we created before. So it's going to be material.matcap equal, and we use that texture that we got from the use matcap texture. If we save, sometime it's going to work, but not always. See, when I just saved, when the hot module replacement happened, it worked. But if I give it a reload, it's not working. And maybe you're going to get a different result. I think you're going to get the same as me. Anyway, there is an issue where we just need to ask the material to be updated. Because when the material is created, it's being created without the matcap texture. And when you change some parameters like the matcap, you need to tell it like needs update. Update yourself. I did some changes. Now you need to update yourself because 3GS need that because it's going to update the actual shader, and 3GS try to do that as less as possible. So when we need to change something, we need to tell him this one needs to be changed. And the matcap is one of those properties. We need to warn 3GS about that. And we get something weird. Okay, give it a reload. It seems to be working, but it looks a bit bright. What just happened? Well, the texture looks too bright because when you use the classic 3GS or the mesh matcap material component in the GSX, React 3 Fiber will automatically take care of the encoding, the sRGB encoding thingy. It will take care of everything for you and make sure that everything matches, and that's great. But when we did some custom 3GS, native 3GS mixed with React 3 Fiber, well, things got a bit messed up and the encoding hasn't been set properly on the texture. So we need to do it manually. That's all. We just need to tell that matcap texture that the encoding should be 3 sRGB encoding. So let's go. So it's the default good encoding. Matcap texture.encoding. We are doing it only on the first, after the first render, so inside the use effect. Equal, and we use 3.sRGB encoding like this, and we already have access to the 3 variable because we imported it to create the torus geometry and the mesh matcap material. And again, that's the kind of geometries that needs you need to warn 3GS about the update. So you set needs update on the matcap texture and you set it to true like that, and the color is back. Nice. We are using the proper encoding everywhere. That's cool. We are almost done. So as you can see, I don't know, what's your favorite solution? Doing it like fully internally React and React 3 Fiber with some weird tricks, ping pong variables, etc., or creating it outside? When it comes to geometries, well, it's fine to create it outside like that. We just created outside and used it. But when it comes to materials, sometimes we need to do some tricks, some flex, like using the use effect, etc. So it's up to you. You can use whatever you want. Through the next lessons, we are going to use both solutions when it's relevant to use one of those solutions. And we're going to go a little further. We're going to animate the donuts because, as you can see, we went quite fast. Although we explained everything and took our time, it went quite fast. We're going to push everything a bit further. So let's go. First, we are simply going to make the donuts rotate like this. That means we need to access those donuts. Remember, to animate stuff, we do it in the use frame. And in the use frame, usually we use a reference so that we can access the object and rotate it. But we have an issue. We have 100 donuts. If we add a ref right here, like a ref right here, well, this is 100 meshes. If we create one ref, maybe it will be the last one, maybe it will be the first one, I don't know, but just like that, by putting a ref like we used to do, it's not going to work. So we need to find some solutions. And it can be a bit tricky. I always find having multiple instances that you display using a map or whatever solution, like a list, to have reference to the list, I think it's a bit too tricky in React to do it. There are solutions, don't worry, we're going to see 2 solutions. So let's go. First, we're going to use a group. Why a group? Well, because the group inherits from object 3D. In 3JS, I'm talking about 3JS. A group inherits from object 3D, just like a mesh inherits from object 3D, and those have children. Meaning that just by adding a group around the meshes, we add a reference to that group. So we have just one reference associated with one group, and then we can access the children of that group. Let's do that. Let's try that. So we're going to create the group outside of the mesh and outside of the map. So it's going to be something like that. So group, we indent the whole array like this, and we close it after. All right, it looks like that. I just created a group around it. Next, we are going to use useRef. So let's go. Use ref like this. And we're going to create a reference to the group. I'm going to remove those comments right here. I don't want them anymore. Up. And I'm going to remove the use state too. They are messing up with my code. In here, I'm going to create the donuts group. So donuts group equal use ref. So it's a reference. And I'm going to associate it with the group. It's the usual reference. There is no trick right now. Ref equal donuts group, just like that. And now I have a reference to that group right here. So can we update the donuts now? Yes. First, we're going to use frame. So the usual from. Okay, we don't have a React 3 fiber yet. I'm going to put it there. So use frame from the classic React 3 fiber, because we want to update on each frame. We want them to rotate on each frame regardless of the frame rate. And in there, I like to do it right before the return, although it doesn't make a difference. Use frame will provide a function like this, and if you put a log like frame, see, we have it's being called on each frame like that, and it's working. Nice. We are going to animate the donuts, and we want the same animation for everyone, regardless of the frame rate. We're going to use the delta I'm going a bit fast on this one because we've seen that so many times. To get access to the delta, we can get it from the second argument of the use frame of the function we provide to use frame. I just put the state because we need to put something as the first argument to get access to this one here. And if you log it, you get the time between the frames, and it looks something like that since it's running at 60 frames per second. In my case, I get 0.016, which makes sense. If you have a higher frame rate, this one will be smaller. And then we're going to rotate them. So I'm going to remove the console log like this. We're going to rotate the donuts, and that's the whole point of having the group. If we want to access to all the donuts, we can do it by accessing the children of the group. And I can show it to you, like log donuts group dot current. Never forget the current. I always forget about the current. Children, and right here I get an array with 100 meshes in it, and those are the donuts. Nice. So I'm going to remove the console log because it's a bit too much for Chrome, and I'm going to do a classic for loop. So for const donut of those children inside the group. Okay, it's a traditional way of looping on an array. It's a for of loop, and you get on each loop the donut. And we're going to update that donut. This is a classic JavaScript. We're going to update the donut. So donut.rotation.y. I'm just going to do plus equal, I don't know, like 0.1, and they're rotating. And now I'm going to use the delta so that they're rotating at the same speed for everyone, regardless of the frame rate. And check that, they are rotating. Quite slow, but it's on purpose. I don't want it to rotate too fast. Nice. And that's all. We don't need to do like in one direction or the other, because since they are rotated, some will turn like this and some will turn like this. So it will look random anyway. And they are rotate at the same speed, but that's already more than enough for the lesson. So that was the first solution. I don't know what you think about that. It's working. My main issue with this solution is that we created a group to just fix a flow, a structural flow. See, the group, it's not, the purpose of the group is not to group things, it's to have access to its children. It's okay. In terms of performances, it's perfectly fine. Instead of code complexity, it's okay too. But it's a bit weird to use a group for that purpose. And I'm going to show you another solution, but unfortunately that other solution is a bit more complex too. So it makes more sense, but it's also a bit more complex, and you can choose whatever solution you prefer. First, you need to understand one thing. A reference is only an object with a current property, right? When you do this, so donut group, like that, it's just an object with a current property. What if we create that object ourselves? Will it work? Well, yes, it will work. We're going to do it kind of manually. You will see. We're going to create a reference. We're going to set it as an empty array. And then we're going to fill that array. We're going to get rid of the group, okay? We're going to create a reference, put an empty array in it. So it's going to be current empty array right here instead of the group. And then in there, we're going to find some way to fill that array. We're going to put the meshes inside that array. So that we have a reference composed of multiple elements. It's an array, a reference array, and it's going to work. You will see. So let's go. First, we're going to do some cleanup. So I'm going to remove that one here. Okay, I'm removing the group, so the opening tag and the closing tag. I can remove this line break here. Then I'm going to comment this part because it won't work for a moment because we don't have any more group. Just comment it because we just need to change one or two line, and it's going to work with that new solution. And now I'm going to get rid of this part. Okay, the donut group here. Keep the use ref because we are still relying on the reference. Okay, nice. Then in there, we are going to create a new reference. You can just modify the old reference if you want. It's going to be const donuts with an S, so it's not the group anymore, it's just donuts, equal useRef, and check that. When you provide to useRef something, this something will be used as default for the current right here. And you can test that. If I just log the donuts, it's going to be an object with an empty array in it. That empty array right here. Nice. We can move forward. how to fill that array with the meshes. Where we scroll down to the meshes, so those are the donuts, and we're going to provide a ref, but don't save yet. Check that. If we provide the ref like this, it will put that mesh into that reference. And the next one will be put in that reference, and the next one, and the next one. My guess it's at the end you get the last mesh inside that difference. That's not what we want to do. No, instead, check that, we are going to provide a function. And when you provide a function to ref, this function will be called, and the actual element will be sent as the parameter right here. So doing that, we can retrieve the element. So it's going to be the donut, and I'm going to call it element, why not? And I'm going to fill that array. So donut current push the element. All right, I'm going to push the element inside that current, which is just the empty array. So let's go. I'm going to do donuts current, don't forget the current, push the element. Just like that. I'm going to save it, and that's it. We push the elements inside that array, and we should have access to it, but we did a mistake. Every time the experience component is being re-rendered, we're going to push elements in that array. Meaning that we're going to keep filling that array. We're going to push 100 donuts in that array. So imagine that's your array, it's empty, and we're going to push 100 donuts. Okay, cool. If the component re-render, it's the same meshes. Okay, maybe the component re-render, but the meshes didn't change. Okay, React and React Prefiber will take care of not creating new meshes. But the reference, the code right here that we just wrote, will be executed again. And we're going to put to that array, we're going to put one more time the 100 meshes. So we get 200 meshes, and those are actually the same meshes. And if the component re-render, and see we get a bunch of renders, it will keep adding the same 100 meshes and 100 meshes and 100 meshes. So it's a bit messy, and if we loop on them and rotate them, some will they will all rotate too much because there will be multiple time in that same array, and after some time, well, your array will be I don't know, like super big. So we did a mistake here. Can you guess how to fix that? There is kind of a silly but a good solution anyway. We are going to use the index of the map, okay? Because the index of the map goes from 0 to 99, okay, 99, and we're going to use it instead of just pushing at the end of the array. We're going to put them at specific position, and we're going to put them at the 0, 1, 2, 3, 4 until 99, and then if it's being called again, we're going just to put them at the same places. So it's fine. At the end, we will always have an array which is 100 items long. And to do that, so instead of doing a push, so that's our array right here, we're going to add them at the index equal the element. All right, when you push, it adds at the end. If you want to send at specific position in the array, you use that technique. This is just native JavaScript. We save. I think it's working. Let's give it a try. Back to the animation. We are getting each donut from not the donut group thingy. We are taking them from the donut reference, which is an array. Okay, so the current is an array. Our donuts are supposed to be in there, and we don't care about the children thing. This was when we used the group. You need to give it a reload, and now it's working. Nice. So, which one is your favorite one? Actually, I think I would go for the group. I don't know. It really depends on the project. Maybe with who I'm going to work. If it's beginners, maybe I will try to use the easiest solution. But I found this trick here a bit weird. And React beginners are going to be, what the hell is happening here? We are using a reference, but we are sending a function. And we are putting stuff inside the current directly. What the hell is happening? So maybe I will go for the group instead, because in terms of performances, it's fine and it's easier to understand. And you get a smaller reference. It's just a reference to one group. And sometime in other circumstances, maybe I will do it differently. It's up to you. You do whatever you want. I just wanted to show you different solutions to do it. Okay, and we are done with the lesson, and I will see you in the next lesson.